Alright, so if you're watching this, you probably came from the other video, integration using partial fractions. And yeah, if you didn't watch that video yet, go watch that video first. Yeah, just search up integration using partial fractions inside my YouTube channel before watching this one, because there I explained how we got the A, B, C values. And yeah, so if you've already tried this integral by yourself and finding all the A, B, C values, yeah, so now we're going to solve and see what the correct answer is. Okay? So, yeah, so, right, as I'm sure you probably did, right, you can just plug back in the A value first. So 1 over 5 over x plus 1 d of x plus the integral of negative 1 over 5 x plus 1 plus 5 over x squared plus 4. So now, this is going to be the integral of 1 over x plus 1, and we're sort of decomposing this integral again, right, so that we can make it easier for ourselves to solve it in the end. Okay? Oops. Yeah, so it's going to be minus the integral of x over x squared plus 4. Alright, d of x plus, right, according to our division rules, it would have to be 1 over x squared plus 4 d of x. Now, as you can see here, all of this, we just now created in a large expression that is much easier to solve than this expression right here. Okay, because, right, how are we going to kind of sort of solve the integral of negative 1/5 x plus 1/5 without actually over x squared plus 4 without actually breaking it up? So now that we've broken it up, we can just use our catch terms, like here, for this one here, we just have to use u substitution, whatever u equals to, right, in this case, x squared plus 4. And this is really the beauty of partial fractions, right? We can just, as we go on, we can just sort of keep on splitting up our integrals, right? We started out with one integral right here, and then look where we came to now. We've now created 3 simple integrals that we can solve, right, probably with no mistakes. Okay? Yeah, so that's, again, I told you, that's the beauty of partial fractions. So when we solve this, we're going to have 1 times, well, what is the integral of 1 over x plus 1? Well, that's not too hard. You just use ln, right? You just use the ln function. And then, what is the integral of x over x squared plus 4? Well, this is a little bit trickier because we have to use u substitution for this one. So u, in this case, would have to be equal to x squared plus 4. So then, du is equal to 2x d of x, which means that we're going to have negative 1 over 10, right? Because it's going to be, the x's here are going to cancel out. Okay, and then we're going to have negative 1/5 times 1/2. And then our ln, right, in this case, is going to be, right, since our u is equal to x squared plus 4, it's going to kind of sort of morph into this integration problem here, right, integration of this. So the integration of 1 over u, well, that's just ln of u, and our u is just going to be equal to, u is just going to be equal to x squared plus 4, which means in terms of x, it will just be ln of x squared plus 4. Okay? Now, at first you might think this integral right here is kind of hard, but it really isn't, because remember that if you gotta remember your trig functions, remember that, right? You know that the derivative of tangent of x is going to be equal to 1 over x squared plus 1. Okay? The derivative of this. And as you can see here, we sort of have the same format here, except we have plus 4. But that's not an issue, because if you remember from the tangent integral formulas, right? One of the formulas for tangent integrals is 1 over a times the tangent of negative 1 of x, or whatever variable you're using, or yeah, we'll just call this the real formula is u. In this case, it would be x is u's x over a. Okay. Now there are many other formulas that you have to memorize. So I would suggest memorizing these trig formulas, so that when you run into cases like such as this, you'll be able to solve it within an instant. Right? This is much easier on your exams to solve using these formulas, so that you can avoid going through trig substitution and all that. Okay. So in this case, our a value would be 2, right? Because it would be x squared plus 2 squared. So our a value is just equal to 2. So when we do that, a value is equal to 2 and u value is x. We're going to have an answer of, well, not an answer, but this integration. Yeah, this integral will be equal to 1/5 times, or not 1/5, my bad. Have 1/5. Right? We could have write this as 1/10, but for now, I'll just simplify it later. So 1/5 times 1/2 of tangent inverse times, right, x, and then our a value is 2. That's why we wrote the 1/2 here. Okay, x over 2. Okay, plus c. And then we can just simplify this. So when we simplify this, 1/5 times 1/2, we're going to have 1/10. So 1/10 times the tangent inverse of x over 2. And let me just put the plus c bit, over here. Okay, and that's our answer. Okay. Yeah, it's a big answer from this seemingly small integral right here. But yeah, again, if you just keep on breaking it, right, into a over something, b of x plus c or something, or even b x squared plus c x plus d or something, right? It just depends like what the powers are. Again, if it's x squared, linear, x constant, cube, quadratic, and what you know is that it's always the numerator of whatever you're writing it on, whatever is going to be 1 less than the denominator. So here a is a constant, and a constant is 1 less than linear. Here, bx plus c, the standard equation of a linear, right? Remember, you got to write your standard equations, is 1 less than the denominator, x squared plus 4. Okay, so b of x is 1 power, x squared is 1 power. So yeah, so it's the power on the numerator is 1 less than the power than the highest power on the denominator. Right, and yeah, just keep on splitting it, and then you finally get your answer. Okay, I hope this video helped. I tried to go in depth into partial fractions as possible because they can be tricky sometimes, but there are definitely harder and more trickier partial fractions and rules that you should probably memorize, especially if you're in college. But yeah, if you want me to do those videos, just type in the comments if you want harder partial fractions, and yeah, I'll do them. Thank you and have a good day.